Hello everyone, in this video we are going to see how to implement a mecanum wheel drive in Isaac Sim using the ROS2 bridge. So let's get started. Open Isaac Sim. Here also I am using the workstation installed Isaac Sim. Firstly, we need to have the correct robot file for this drive. For this, I have used a repository from a YouTuber. He has already given a good example of it, but in his video, he has controlled the robot using a direct Python script without ROS2, so we are going to use his USD file for this tutorial, and I want to give credit for it too. The link for the repo and the YouTube video can be found in the description. So clone the repository to your home directory, and in Isaac Sim, under the content section, open that folder which is RB_wheeled robot example, then USD, then wheeled robot, and then collected_Summit_XL_Omni_4. And here you can see the USD file of the robot with the mecanum drive. So drag this USD file to the world prim. Now we need to add a ground plane. So go to Create, Physics, then select Ground Plane. Now here you can see these mecanum wheels. To control these mecanum wheels, it is necessary to configure their physics correctly to move these wheels in simulation. So let's fix this physics. Firstly, we need to check the collider preset. So click this eye icon, Show by Type, then Physics, Colliders, and click on All. Here you can see that the collision for all wheels is not around the whole wheel, so we need to fix this first. Go to the Stage panel, select the wheel prim, and under this prim there are 7 prims for its rollers, and we need to fix the collision for all rollers. So let's start with this first roller. Click and select the prim. To edit its properties, we need to untick instanceable. Now click on the roller, and under the Properties section look for its collider property. But here I am not able to find it, so we need to add the collider property. For that, right-click on the roller, then Add, Physics, and click on Collider Preset. Now again look for the collider properties in this section. So here is the collider property. Under this, we need to change this approximation from convex hull to SDF mesh, because SDF mesh provides a more accurate collision shape for complex geometries. So now you can see the change of the collision. Now the collision is all around its roller. I will show this process again. Select the roller prim, untick instanceable, add the collider preset, and change the approximation from convex hull to SDF mesh. Follow the same procedure. And now you need to do this for all rollers for all wheels. So now I have done these changes for all wheels, as you can see here, so we have fixed the collision for the wheels. Just remember one thing, after doing changes in the prim, do not click on instanceable again, otherwise your changes will not be reflected. Now next is to configure the joint properties of all these rollers. So select any roller joint, and go to its properties. Here you can see they have added the drive for this roller, but we do not need this drive, as these rollers should move freely irrespective of control, because these rollers are passive and must rotate freely for mecanum motion. So we need to remove this drive. So click on the cross icon and select Yes. Similarly, for all these roller joints, please do this procedure for all rollers of all wheels. So I have done these changes for all joints. Then let's first hide this collision. Now these are the main wheel joints for its 4 wheels. We can check that by giving target velocity. So let's check that. I am giving 100 as the target velocity and run the simulation. And here you can see that our robot is moving clockwise, even though I have given the same velocities to all wheels. The reason is that its revolute joints are mirrored. That is why their directions are opposite. So when we write the code for this control, we need to keep that in mind. I feel that understanding this tutorial will be hard, as its physics and drives are quite different, and there are other possibilities to configure this robot. And also, if you are using a different robot, there might occur different errors. So to learn and solve these problems, I am making a Discord community. I request you all to join this community server, where I have already made some categories. Like in the tutorial forum section, we can put our errors regarding the tutorial with proper tags, and we can help each other. Also, there is a general discussion channel available too. You can find the invitation link in the description. I will be happy to see you there and create a good community. Now, to control this robot with the ROS2 bridge, we need to create an action graph which controls the target velocity. As we have already created an action graph for four-wheel differential drive in the last tutorial, I am going to utilize the same action graph. You can find this action graph in the last tutorial's description. So drag this action graph into the stage world panel, duplicate it, and delete the imported one. Now rename it as mecanum_drive and open it. So let's start. As I said, we need to give opposite angular velocities to two drives. So we need to have one more differential controller, meaning a separate differential controller for the front wheels and another for the rear wheels. So add that differential controller in the action graph. Next, disconnect this connection as we want separate control and connect it with the other differential controller. Connect tick to exec in and time to DT. So for the other differential controller, I am going to use the Y vector component of angular and linear velocity to give the velocity commands. So connect Y to desired angular and linear velocities respectively. And here you can see that we need to give this command on the cmd_vel topic. Now for both controllers, we need to configure the robot specifications. So here the wheel radius will be 0.127, and the wheel distance will be 0.3755, and max velocity 100. Do this for both controllers. Now final step is to give the joint names to the articulation controller. So let's do that. First we need to give the front wheel joints, which are FL_joint and FR_joint. Then for the rear wheels are L_joint and RR_joint. Then give the target prim in the articulation controller, which is Summit XL Omni 4 for both controllers. Now we are complete with the action graph. So let's save this graph. You can find all these files in the description of the video. Now let's start the simulation. And we are not getting any error. Now we need to publish the twist message on the cmd_vel command. You can check my previous tutorial on how I have done this. Here I have already prepared a script for it. So open the terminal and source the ROS2. Go to the directory TET9 and run the Python script Teleop_mecanum. Make sure that you have connected the controller to your system. For me, it is showing connected, so let's check. Our robot is moving forward, backward, anti-clockwise, clockwise, sidewise right, sidewise left, so we are able to control the mecanum drive in Isaac Sim. You can try with your robot, and let me know your experience in the comments. If you like this video, please like and share this video with your friends, and do not forget to subscribe to my channel. Thanks for watching.